Hello, my name is Dawid Rymarczyk, and today I will present joint work between Jagiellonian University and Computer Vision Center in Barcelona called ICICLE, Interpretable Class Incremental Continual Learning. The main motivation behind this work is interpretable continual learning and its robustness to interpretability concept drift. The concept drift is the change of the activation of a visual concept on the image so that the user can be misled by the explanations when the model is learning continually. We propose architecture inspired by Proto-PNet model from NeurIPS 2019, where we are adding a group of prototypes for each task. And we also changed the last layers of the last tasks, where the connections between the prototypes assigned to a given classes are initialized to 1, but the others are 0. Our first contribution is the interpretability regularization loss function, where we want to preserve the most information as possible about the activation of a given prototypes when we are learning a new task. The second one is the proximity-based prototype initialization. As the model already knows what is the bird's head and bird's tail, we can initialize new prototypical parts around already existing one, so we can place them properly in the latent space. Lastly, we propose task recency bias compensation, where we are balancing the tasks. So the activation of the prototypes from the previous tasks are lower than the original one or the last one. So we are balancing them with a constant after training the whole model. We tested our model on Cube and Stanford cars. Here you can see the results for task-aware and task-agnostic accuracies. And we compared our ICICLE method to the baselines in continual learning for task learning scenario. And here we are comparing ourselves to methods on 4, 10, and 20 tasks. Here you can observe the results between how each component that we introduced influences the results. As you can see, the combination of all of them is the best for task agnostic accuracy. And the most important table, here you can see the interpretability concept drift. The higher, the better, because it shows how much the concepts are consistent between the tasks that were learned from the previous tasks. And as you can see, the ICICLE is the highest above all of the baseline methods. Our work has obvious limitations, so non-obvious prototype, meaning which is inherited from the Proto-PNet. There is still the gap between interpretable and non-interpretable methods. Also, this method is very sensitive to the change of the loss function or hyperparameters, and we did not consider pruning as it was done by other prototypical parts-based methods. And to conclude, we provide a benchmark for fine-grained class incremental learning with interpretability. We propose the ICICLEs. And as a next steps, we would like to use the Protopool or other concept sharing architecture in class incremental learning. And also, we would like to know how to learn those concepts, visual concepts, in a self-supervised manner, so we can follow the newest, the most novel approaches in class incremental learning, such as FedFree. So in that way, we could narrow down the gap between interpretable and uninterpretable methods. Here you can have